Hello everyone, in this video we are going to see about the priority queue. We know that queue is a first in first out data structure and the term priority means a preference. So here let us see definition. A priority queue is an abstract data type. It is similar to a regular queue or stacked data structure in which each element additionally has a priority associated with it. In a priority queue, an element with a high priority is served before an element with a low priority. Actually, here along with the elements of this queues, we also have one more element which is the priority element. So, based upon the priority, whether it is high or low, the element will be processed. Normally, the element which is in the front will be processed in the queue. So, in the case of priority queue, the high priority element will be pushed to the front of the queue so that it will be processed. Okay. So, now let us see how the order is determined. The priority of the elements in a priority queue will determine the order in which the elements are removed from the priority queue, because only if it is removed which is in the front, then only it can be processed. So the order will determine, the priority will determine the order how the elements are has to be processed. The priority queue supports only the comparable elements, which means that the elements are either arranged in an ascending or descending order. Actually, that means the data in the queue, the values in the queue will be either in the ascending or descending order, because they have the priority which is comparable to the successive elements. For example, suppose we have some values like 1, 3, 4, 8, 14 and 22 inserted in a priority queue with an ordering imposed on the values is from the least to the greater. That means the values are from lower to the higher values, 1 to 22. That means this 1 has the highest priority and 22 has the least priority. So based on this order only, the queue will be processed, not as we have as the first in first out. So the elements will be arranged in ascending or descending order, and the higher priority will be given to the first element which is in the least in the value. Let us see the characteristics of a priority queue. A priority queue is an extension of a queue that contains the following characteristics. So what are they? Every element in a priority queue has some priority associated with it. That means the element is not just an element, it also has the meaning to tell what is the priority of the particular element in the queue. And an element with a higher priority will be deleted before the deletion of the lesser priority. Actually, the elements are deleted when it is moved to the front. That means it is processed. So the example is, when the people are standing in the queue for getting the tickets, the front person will be given the ticket and he will be leaving the queue. That is, he will be removed from the queue. So that is called deletion, means removing from the queue. When we will remove the element from the queue, once it is processed. Okay, so when the higher priority element comes, it will be processed and removed from the queue. If two elements in a priority queue have the same property, they will be arranged using the FIFO principle. For example, there are 5 elements which has the same priority as 3. For example, in that case, among this third priority, the elements will be arranged, will be processed in the first in first out principle. Let us see with the example to understand the concept clearly. So now this is the diagram which is the priority queue data structure. So as we know that a queue is a first in first out data structure having the rear pointer as well as the front pointer. We know that from the front we delete the value and from the rear we push the value. So from the back or the rear, that is the NQ, enter in the queue, insertion operation, whereas in the front it is removing or dequeuing. That means deleting from the queue, dequeuing operation. Okay, so now this is the normally the diagram of the queue will be with the front and the rear elements for enqueuing and dequeuing. What is the additional in this priority queue is the first element which is in the order has the highest priority, which is the least element. the least elements gets the highest priority, then comes 500 and then 750 and then 900. So when the element comes to the queue, they will be arranged in such a way that the least element which has the higher priority is pushed first to the queue, then followed by the consecutive elements, higher elements. Let us see how insertion and deletion takes place in an array. We know that which is an array implementation form. Here the priority queue is implemented using the array data structure. So what we have to do, find the smallest k such that front of k not equal to null. Actually we are going to process only the front element in the queue. So what you have to do, we have to find out the smallest element among the elements in the queue, and that element should be pushed to the front of the queue. In the case that it is not equal to null, means the front element has some data. So this is the way the priority will be given to remove from the queue, which is the deletion operation. Delete and process the front element in row k of the queue. So once you find the smallest element, we just push the kth element to the front of the queue, and then that element will be deleted and processed and exit. This is the third step. How to insert the element in the priority queue? So we have to find the element, insert the item as the rare element in row m of the queue. So now once you have the element to push or to add into the queue, that has to be done through the rare element, as the rare element means the last element of the queue. Exit. So this is generally how the element is pushed in the back and they are processed in the front. Now let us see the diagram of the linked data structure, linked list data structure. Earlier diagram what we have seen is the priority queue in terms of an array. Now we are using the priority queue using the linked list concept. So generally how we use the linked list, we are using the linked list followed by the data and the address. So here instead of this address, we have one more field called the PNR, which is the rank. Okay, so now this rank means the priority number, shortly called PNR. Okay, so now how to follow the link? Initially the element starts with 0, which is the element 200. But in the case of this priority queue, we have to first look for the priority from this list, from this point. So now 1 is the highest priority, the first priority. So we have to start only from the process which is 300. Okay, and then from this process we have to follow the link. So what is the link here? Link goes to 0. What is 0? In the 0th position, the value 200, which is the priority 2 is there, and then from 2 the link goes to 4. So where is 4? In 4 we have the next value which is 100, but the priority number is also 2. So here there is a case when the elements have the same priority, that is 2 as the priority for both 200 and 100. But how they will arrange? They will arrange in the first come first serve order. So this 200 comes first in the queue, even though this 2, the priority of this data 200 and 100 is 2. By this order 200 comes first and then only 100 arrives next. So among the same priority, FIFO principle is followed here. So followed by this, here 2 is the next number. Then to the link, if you follow, the value is 5. So where is 5? 5 goes to the element 600. That shows the priority 3. Okay, then from 3 where you have to move, we have to move to the element 1 through this link pointer. So what is actually 1? 1 is the value which is having the data 100 and the priority number is 4. And then this priority, this 4 goes to the next link 2. So where is 2? 2 has the next number 500, but the priority is also 4. Again this link points to 6, where the 6 is the number which is 700 is stored, but again the priority is 4. So we can see that the priority values for this 400, this 500 and 700 are equally 4, 4 and 4. Among this same priority number 4, 400 is processed first, then 500 and then 700 because they are in the first come first serve order. So first come is the 400 and next come is the 500, even though they have the same priority, and next we have the number 700. And after following this pointer or this priority number has no followers, it is the link, that means the list is ended. Let us see how the same is given as a diagram, linked list diagram. Okay, so how to the linked list diagram is given over here. So this is where the link is given. So start the first priority, the element is 300, then it points to the next element which is priority 2. Even though both are 2, first is 200 and second came is the 100, and then 400. The priority for this value is 2, 2 and 2, but they come in the order 200, 100 and 400. Then the priority is 4. Even though 4 is the priority for both 500 and 700, 500 came first in the queue and then 700. Finally, the fifth priority, which is the value 600. From here, there is no point. This is the end of the list. So this is how the linked list is represented using the diagram for the priority queue. So how the deletion and insertion occurs in the linked list form? Deletion from the queue is done by set items equal to info of start. So whichever the element in the starting position, that is moved to the end because the starting position has the value with the highest priority. Delete the first node from the list, that node is processed, then process the item exit. So how to insert into priority queue? Traverse on the one-way list until finding a node X whose priority number exceeds n. Insert item in front of node X. What does it mean is find out the position for the node X, checking the priority number. If the priority number of the selected number which we are going to insert is more, we have to keep on finding the element which has the least priority. We have to push the value into that node. If no such node is found, insert the item at the last element of the list. So if there is no priority, the priority is given but the priority is less than the incoming value, then we have to insert the item as the last element of the list. So this is how the deletion and insertion takes place. The concept is simple. Whichever you want to delete, you push to the front of the queue, which is the starting of the queue, and then the item will be removed because always the front element is processed from the removed and processed from the list. In the case of insertion, check with the priority in the list, and because we know that the highest priority element should be inserted into the front of the list. If no such element occurs, then push the element to the last element of the list. So that's all the concept of insertion and deletion in the priority queues. And you have seen the diagram also how the priority comes in order with 1 and then 2 and then 4 and then finally 5. So that's all the representation of priority queue using the array and the linked list format. I hope it is easy to follow, and thanks for watching.